Okay, in this video we'll be going over the equation of the tangent line. So there are two ways to write this equation. One is in the point-slope form, and the second is in the slope-intercept form. Both are useful. Sometimes in an equation you'll need the point-slope form to solve for the answer, but it'll give you the slope-intercept form originally. So it's important to be able to distinguish between the two and be able to successfully use both. So for the point-slope formula, we have y minus y naught equals m times x minus x naught. So the y naught and the x naught are just coordinates of a point on a line. So if a question writes 1, 2 as the coordinates of a point, this would be our x naught, and this would be our y naught. That's it. Pretty simple. The m just equals the slope right here. That just equals our slope. Pretty simple. So then the slope-intercept form is y equals mx plus b. The m, again, it's our slope, but the b is our y-intercept. Don't forget that. Let's move on to using this in questions that might appear on the homework or exam. Okay, I forgot to say this, and I just forgot to say this earlier, but these will be calculus questions. So if you are looking for something else, this is the wrong video to watch. But here is a way that the equation of the tangent line might be used in homeworks or an exam. So here it is. What is the equation of the tangent line on the graph of y equals x to the fourth power minus 4x at the point 2, 8? Okay, so the first thing that we need to find is the m. Remember, from either the point-slope formula or the slope-intercept formula, the m is equal to the slope. So how do we get the slope? Well, we're going to need the derivative. Okay, so we need the derivative of y equals x to the fourth power minus 4x. So the derivative would be 4x cubed minus 4. That's it, okay? All right, so we have our derivative. Our next step is to plug in x. What is our x? Well, it's right here. It tells us that the point is 2, 8. And the 2 is the x. So we're going to plug in 4, 2 cubed minus 4. Hopefully everyone is still following so far. So if you work out this math, it will equal 28. Pretty simple. Input it into a calculator or just work it out in your head. The answer would be 28. So this tells us that our slope, m, remember, because it's denoted by m, will be 28. So we've gotten that far. Oh. Sorry, I chucked my pencil all the way across the room. All is well. Okay, so let's just remember the slope is equal to 28. Let's put that aside for now. So it's telling you our original point is 2, 8, which of course is written in the format x, y, which means our x naught would equal 2, and our y naught would equal y. I mean, not y, sorry, it would equal 8. Okay, so let's remember the formula, which is and this one we'll be using the point-slope formula, which is y minus y naught equals m x minus x naught. So we already have our y naught, right? We have our m, we have our x naught, which is all that we need. So let's just go ahead and plug everything in. So we would have y minus y naught, which is 8, equals our m, which is our slope, which we solved earlier, which is 28. And then we have x minus x naught, which is 2. That's it. So let's just work out some of the math here. So we'll still have y minus 8, and that will equal 28x. All I'm doing is distributing this 28 right here. And that would be minus 56, right? So let's try to get the y alone here. So we're going to add 8 to this side, add 8 to this side. So that would leave us with y equals 28x minus 56 plus 8, which would leave us with y equals 28x minus 48. And this right here would be our final answer. That's all. That's it. You've done it. This is one way to use the equation of the tangent line. Okay, here's our next example. So we have this function right here, and this question is asking us to find the equation of the tangent line at x equals 0. So here's another format that is typically used. So we have y, a function evaluated at a, equals the prime, or the derivative of that function, still evaluated at a, x minus a. So in this equation, our a equals 0. It's just this right here. There are also many ways to write this. People switch out the a for many letters, but it's all the same thing in the end. Okay, so then let's just start off first by plugging in that 0. So we're going to have y minus this function evaluated at 0, the derivative of this function evaluated at 0, x minus 0. That clears things up, at least for me. I hate it when there's multiple letters. So this is all we're doing. So we need f of 0. So this just means the original function, which is this one right here, evaluated at 0. The prime of the original function, still evaluated at 0, and then x minus 0. So let's just start with the original function. F of x equals 2ex plus 2x cubed. Let's just plug in a 0. Okay, so we have 2e0 plus 2, 0 cubed. And if you work all this math, put it in a calculator, it would equal 2. This would go to 0. E to the power of 0 is just 1 times the 2 would leave us with 2. Okay, we're just going to leave that for now. Okay, so now we're going to take the derivative of the original function, which is this one right here. So this would just be 2ex. The derivative of ex is just itself, ex. That will always be true. And then the derivative of this portion right here would be 6x squared. That's it. That's all we need for that one. Okay, but then remember we have to evaluate it at 0. So let's just plug in a 0. So that would be 2e to the power of 0 plus 6, 0 squared equals. Okay, so this again would just go to 0. And then this right here, e to the power of 0 is just 1 times the 2 equals 2. Okay, so we know that the original function evaluated at 0 equals 2, and the derivative of the function evaluated at 0 also equals 2. So all we have to do now is plug it in to the original format, which is right here. So we have y minus the original function evaluated at 0, which is 2, equals f prime of 0, which is just the derivative of the original function evaluated at 0, which is also 2, and then x minus 0, like this. Let me bring my work over here. I'm running out of room. Okay, y minus 2 equals 2x minus 0. I just rewrote what I had. So let's go ahead and distribute this 2. So that would leave us with y minus 2 equals 2x minus 2. Right. Wait, hold on. No, yeah, that's right. Wait, what? No, that's right. I'm sorry. Okay. So then we're going to add 2 to both sides. No, that's wrong. Sorry. I got it now. Sorry. So here, to get the y alone, we're going to add 2 to one side, add 2 to the other, which is going to leave us with y equals 2x minus 0 plus 2. Okay, so then we're going to distribute that 2, which would give us y equals 2x minus 0, because that 2 times the 0 equals 0. Sorry, earlier I was thinking it would be 2, but that was wrong, sorry. Okay, so we're just going to distribute that 2, which would give us 2x minus 0 plus the 2. So then let's just get rid of the 0 and simplify it a bit more. Y equals 2x plus 2. So remember, the original question was for us to find the equation of the tangent line at x equals 0, and here it is. And our final answer is in the slope-intercept form. So in the previous question, we used the other format, but here the final answer is in the slope-intercept form. This is our final answer. Let's move on to the next question. Okay, this will be our final question for this video, so let's take a look at it. So we have a function, f of x, and it's telling you when that function is evaluated at -3, our answer is -7. And then it's saying when that function, we take the derivative of it, and we also evaluate it at -3, our answer is -11, right? So it's not giving you a function, but that's okay, we don't need it because it gives you everything else that you need to solve the equation or the question, which is, what is the equation of the tangent line at x equals -3? So we're going to use the equation that we used in the previous question, which is y minus f of a equals f prime of a, and then times by x minus a. So this is, I find this one confusing, but it's still important to remember this one, and to also remember the slope-intercept form and the point-slope formula. Those three are very important to memorize and to learn, and to know when to apply them. But for this one, we're going to be using this right here. So remember, our a is just our -3, right? So let's just replace anywhere we see an a with our -3. So y minus this function evaluated at -3 equals f prime evaluated at -3, and then x minus -3. And of course this later is going to turn into a positive, but we can do that at the very end. So we're just going to plug in everything that we know. So we have our f, original function evaluated at -3, right here. It gives it to us. That's -7. So we're just going to put y minus -7. We'll simplify it later. And that equals the derivative of our original function evaluated at -3, which again, it gives you originally, and it tells you it's -11. So we're just going to plug in -11 here, and our x minus -3. So let's just simplify it a bit more. So our y minus -7 is actually just going to be equal to y plus 7. And then we'll have our -11 times x plus 3, right? So let's just go ahead and distribute this 11 right here to the x and to the 3, which would leave us with y plus 7 equals -11x minus 33. So to get that y alone, we're going to subtract a 7, which would leave us with y equals negative 11x minus 33 minus 7, which would simplify to y equals negative 11x minus 40. So this right here would be our final answer, but if you haven't realized it already, it is given to us in the slope-intercept form. So that's just something to just look out for. In case you don't remember, the slope-intercept form is written as y equals mx plus b. So we know the b is the y-intercept, which for us would be the 40. And then we know the m is the slope, which would be our negative 11. And if it ever asks you a question about graphing, which typically doesn't happen in calculus, but if you're ever asked, you have all the components that you might need.